friends, I welcome you all for another lecture on the course Microprocessor and Microcontrollers. In today's class, I am going to discuss about the introductory part of PIC Microcontrollers. Up to previous class, we discussed about 8051 microcontroller. In that, we gone through different concepts. From this class onwards, I am going to discuss about the PIC microcontrollers. These are very, very important microcontrollers, especially for our projects. So listen carefully. I start my discussion with the introductory part of PIC controllers. First of all, what a PIC is? Peripheral interface controllers. The full form of PIC is Peripheral Interface Controllers. These controllers are designed by microchip technologies. The designers of PIC microcontrollers was microchip technologies. That you have to remember. The full form of PIC is Peripheral Interface Controllers. That is number one. These controllers are designed by microchip technologies. And next, PIC microcontroller have attractive features and they are suitable for wider range of applications. Maximum cases we can go through the projects with the help of PIC microcontrollers. What is the reason for this? If you are thinking in that direction, for that question the answer we are getting from this. This PIC controller have attractive features. So more features, attractive features for designers are found in PIC controllers. That's why they prefer to use a PIC controllers in the designing of their projects. So what those attractive features that we'll go and observe one by one. The first one is PIC controllers are RISC controllers. That is the first thing. What is the RISC? RISC means a reduced instruction set computer. That means the number of instructions present in this microcontroller instruction set have less. Once you have a less number of instructions, it is easy to user to remember all the instructions. And one more thing is, don't think friends the number of instructions in the instruction set of a controller was a less number. That means it can't go and do only less number of operations. It can do more number of operations, but it have a less number of instructions. That means why it have a less number of instructions? The reason for this is, what are the instructions we are not performing on a regular basis? What are the instructions we are performing occasionally? Those operations related instructions are excluding from the instruction set. We are not excluding the operations. We are only excluding the instructions which are used to do those operations in straight manner. Your controller can do those operations with the help of some other combination of instructions. And I can remove the instructions which are used straight away to do those operations. By removing of those instructions, what happens is the number of instructions present in the instruction set was less. That is number one. Once the number of instructions are less, it is easy to make all instruction sizes are equal. Once you make all instruction sizes are equal, then automatically the execution time of the instruction also equal. And not only that, we can go and make a pipelining concept more effectively in that particular system itself. So those advantages also I was getting from that. And one more important thing is, once you have this, your controller have a more number of registers which are available on the controller itself. Once you have a more number of registers available on the controller itself, on a processing unit itself, it occasionally go and communicating with external memories. Once it not going to communicating with external memories, it can't wasting its time. Every time it is depends on internal memory elements, so that the speed of operation of the system also increases. One thing you have to remember friends, once your controller is a RISC, no doubt that controller speed of operation is more. So always the user what was expecting is the application what he was making, that application must be produces results as early as possible. If the results produced by our application as early as possible, no doubt it is depends on what's the hardware we are using for making of it. So that here that is one of the important thing. And next thing is, These are hardware architecture based microcontrollers. We classify our microcontrollers in two categories. One is Harvard architecture and second one is Van Neumann architecture. So what this Harvard architecture is? In case of Harvard architecture, what happens is there are two separate memories, one for code and another one for data. And I use the two separate buses, one for accessing of a code from code memory and the one for to access a data from data memory by your central processing unit. So that in parallel I can access a code information from a code memory and data information from data memory in parallel, so that the speed of operation of the system also increases. And one more variety is Van Neumann architecture. In case of Van Neumann architecture, what happens is we have only one memory. In that memory itself only we can store code as well as the data. And we are using only one bus, so that at any instant of time either I must access code information from the memory or data information from the memory. But accessing of a code and data not done simultaneously, so that the speed of operation of that system is less. So one of the attractive feature of PIC is these are supports Harvard architectures. One, it supports a RISC, due to that speed of operation of your system is increases, and number two is it supports a Harvard architecture, so that it also increases the speed of operation. So these are the two important features. And next, the data memory of PIC is 8-bit wide. What's the meaning of this? That means your data memory size is anything. For example, my data memory is some 8K. My data memory is 8K. That means I have 8K locations. 8K locations. And here it is an 8-bit wide. That indicates each and every location can hold only a byte of information. Then my memory becomes 8 KB. So finally, what is the meaning of this 8 KB? I have 8K locations, and each and every location can hold 8 bit. So your data memory is always each and every location can hold 8 bits. But the number of locations present in the data memory may vary from one PIC controller to another PIC controller. But one thing is very clear, each and every location of a data memory, just it can hold only 8 bits. That was a fix. That is the meaning of the data memory of PIC is 8-bit wide. But coming to the controller, program memory, what happens? Whereas the program memory of PIC is, it may be 12-bit, or it may be 14-bit, or it may be 16-bit. That means you may identify that different sizes of program memory. Not only the number of locations present in the program memory, we can also find the number of bits present in a location. That also varies. If I take a program memory, some 4K words, that means here this word size is, it may be 12-bit, or it may be 14-bit, or it may be a 16-bit. Any size it may be. It may not be 4KB, but your data memory is only B itself. That means word length is just only 8-bit itself. That you have to know about. And next, the PIC instruction set contains only 35 instructions. See here friends, it is very important. The number of instructions present in the PIC instruction set is just only 35. So it is easy to remember all these 35 instructions by a user. A user can remember all these 35 instructions. Once a user have an idea about all the instructions which are present in the microcontroller instruction set, then making of application program is more easy. So that's why here the user need not be put that much efforts to learn these 35 instructions, because comparing with some 8-bit microprocessors or some other 8-bit microcontrollers, you identify that a good number of instructions in its instruction set. But coming to this PIC controllers, just we identify that 35 instructions in the instruction set. It is a more attractive feature of PIC from user point of view, because user need not be put that much efforts to remember all 35 instructions. It is easy from user point of view to remember all 35 instructions. So that is another attractive feature. And next one is the PIC execute most of the instructions within 0.2 microseconds when it operates at the maximum operating clock frequency. Once you operate your PIC controller with its a maximum operating clock frequency, the most of the instructions your controller can execute only in 0.2 microseconds. It is very less time. So this is another feature. And almost all PIC instruction have same instruction format, because the number of instruction here is just only 35. It is easy for us to make all instructions are in same format. So that is another feature. And next, the PIC controllers have inbuilt power on reset and brownout reset mechanisms. So inbuilt power on reset and brownout reset. Generally, if you go for a controllers, what happens is we have a reset signals. By sending off that, your controller can be reset. And here we have inbuilt power on reset, so that automatically we can reset our controller whenever if you want to start your controller operation from the beginning. So that time we are using this power on reset circuit. At the same time, it has one more feature, is it has an inbuilt brownout reset mechanism. This brownout reset mechanism is purely related to power. Once the controller receiving power, it is a less than 4 volts, automatically what happens is your controller was resets. I repeat, this brownout reset mechanism only comes onto the picture once the received voltage of your controller is less than 4 volts, automatically your controller can be reset itself. That means it can protect itself from power fluctuations. So that is about brownout reset. Next, PIC has a fully static design. What is this? It allows selecting any frequency from minimum to maximum in the specified operating range of frequencies. If you refer your 8051 also, you identify that the minimum operating frequency is 1 MHz and the maximum was 60 MHz. We can go and select any frequency in that range of frequencies for operation of 8051. In a similar way, in PIC controller also, it will support a set of range of frequencies. For its operation, we can go and pick one of the frequency in that entire range, and your controller can operate with that frequency only until unless again you modify it or you change it. So that indicates PIC has a fully static design. And next, it supports a power saving mode which is called sleep mode. In case of 8051 also, there are two power saving modes we already discussed in 8051. One is idle mode and second one is a power down mode. In a similar way, in case of this PIC controller, there is a power saving mode which is called a sleep mode. In case of sleep mode, your controller can consume less power compared to the rest of the cases. That you have to remember. And next important thing is it has a watchdog timer. Generally, if you go for your 8051 controller, you may identify that two 16-bit timer/counters. They can be act as a timer as well as a counter. You know that. This PIC controllers also, we have timer circuits, there is no doubt. Those are also act as a counters also. But it has an additional feature, is it has a watchdog timer. It is a very important one, especially for making of our applications. What's the job of this watchdog timer is? This watchdog timer prevents the processor from endless loop hanging conditions. That means your watchdog timer protect your controller. How it will protect your controller is, in regular time intervals, your watchdog timer resets your controller itself. Once it resets in regular time intervals, then automatically your controller operation is normal. If there is no facility, what happens is, by execution of some endless loop, your controller is not come out from that loop itself until unless you turn off your controller, once again you turn on it. But if we are not getting such type of problems by using of this watchdog timer. So your PIC controllers have definitely a watchdog timer. It prevents the processor from endless loop hanging conditions. So that is important. The operating range of voltages for this is 3 to 6 volts. But go to 8051, the operating voltage is 5 volts itself. So by observing all these features, everyone says that these are attractive features of a PIC. We never found all these type of features in some other microcontroller, so that the users prefer using of these PIC microcontrollers for making of their applications. I hope you understand, friends, the introductory part of our PIC controllers. In the next class, I am going to discuss about the family of PIC microcontrollers. So thank you for patient listening. Once again, thank you.